For those of you who don't know me, I'm Phil Johnson. I'm the Director of Public Works. And this is Seth Arns from Western Water Assessment. And he's going to be talking about our local climate. He joined the Western Water Assessment in 2015 and has a very diverse background. And he does these presentations to different municipalities and towns in the Intermountain region, Utah, Colorado, and Wyoming, I'm sorry, yeah. So he's going to give us a discussion on the presentation he provided us at the VCAPS workshop. This VCAPS workshop took place in October 2nd and 3rd of 2018 with a varied group of staff and appointed board members from the Parks and Rec, Planning and Building, City Manager's Office, the City Council, and city staff. And what we talked about was specifically our issues with our water supply and climate and how it's affecting it. So, Seth, I'll just let you kick it off. He's going to give a presentation, and then we'll open the floor to questions and answers after that. Thank you.
Great. Thank you, Phil. Appreciate the introduction. Like Phil said, my name is Seth Arns. I am a research scientist with Western Water Assessment. Western Water Assessment is a University of Colorado-based research program that works to help communities and resource managers understand how changes in climate might impact their management. And we work with them to provide them information and then help, when we can, to help them adapt to those changes coming down the pipeline. So today I'm going to talk to you a little bit about really climate and weather here in Cortez in southwest Colorado. I do want to just sort of introduce, before most of my talk is going to be about climate and weather and future projections of climate change, but I just want to introduce a little bit the project that we worked on with Phil and the city of Cortez. So my organization was looking to work with communities in Colorado and Utah to help them understand how climate risks might be changing. What I mean by climate risks are, in a community, there's certain climate issues that might be more prevalent than others. So in a community like Cortez, drought is certainly a big issue that might come into management issues. And certainly in 2018, it was a very severe drought year. So that became an issue. And we wanted to work with communities to help them understand these issues and to help them adapt to these issues. And so I want to start the conversation by talking about water budget. So by water budget, what I mean is what's coming into our community, into this region, in terms of precipitation. And I think a basic understanding of this helps in thinking about both the current situation and future climate change. So a basic water budget, there's precipitation that comes in the form of rain and snow, and that precipitation leaves our system in terms of runoff and evapotranspiration. What I mean by evapotranspiration is evaporation from soils and lakes and rivers and standing water, and transpiration from plants. And the sum of that is what we have left in our runoff. So on a normal year here in the Dolores River Basin, there's approximately 30 inches of precipitation in the upper basin of the Dolores River. 18 inches of that typically leaves the environment through evapotranspiration, through evaporation from soils, transpiration from plants. 12 inches of that is left for runoff, and that's our water source. That's the water that runs into McPhee Reservoir. and that's the water that's available here for people to use. So during a drought year, we typically have lower precipitation, but not only is there lower precipitation, but there's also increased evapotranspiration. Temperatures are warmer, so that means temperatures are hotter. There's more evaporation from soils and open water bodies. There's more transpiration from plants. So there's more water that's actually lost to the atmosphere than in a typical year. So during a situation of what I'd call severe drought, I started a few slides ago saying average precipitation was 30 inches in the upper Dolores River Basin. During severe drought, that precipitation might be only 20 inches. And then evapotranspiration is 14 inches. So it's a higher percentage of the amount of precipitation that fell. And that only leaves 6 inches of that precipitation left in runoff. So that amounts to only 30% of that original precipitation. So under that scenario where there's 20 inches of precipitation, that amounts to 2/3 of normal precipitation, and the runoff is only half of precipitation. And this is really common. It doesn't equal the amount of precipitation that you have, you don't get the same amount of runoff. If soils are extremely dry, if ecosystems are extremely dry, then you don't get the same amount of runoff happening throughout an ecosystem. And you know, as you see in this slide, even though there was 2/3 of normal precipitation, you only had 50% of runoff, and that's because the ecosystems, the groundwater, the soils were thirsty for that water, and not as much of that water was available left for runoff in the Dolores River Basin. So in what I'd call an exceptional drought, which happened last year in the Four Corners of the United States and here in Cortez, drought was really exceptional. There was only about half of normal precipitation, about 15 inches, and you know, approximately 12.5 inches of that went into evapotranspiration, leaving only 19% of normal runoff available in the Dolores River. So it was an extremely low runoff year last year. This, by all historical records, it was the most extreme drought in historical records. We can look back further, thinking at paleo records, looking at tree rings and things like that. However, within the historical records since about 1900, last year was the most severe drought on record for this region. So to put that in perspective, this graph here shows precipitation in Montezuma County. This is the annual precipitation from throughout the 20th century and into the 21st century. And the main thing I want to focus on with this is there's extreme variability in this. Precipitation varies from 10 inches to 25 inches. And this is a really common trend throughout the Intermountain West, not just here in Cortez. This is a pretty common pattern in Utah and Colorado, that precipitation is just extremely variable. We can't necessarily count on a certain amount of precipitation happening every year. This is going to vary from year to year. And this is a long-term graph that shows this variability in precipitation. The one thing I do want to point out is that the long-term average of this precipitation is about 17 inches. However, here in Cortez in southwest Colorado, you've been in drought since about the year 2000. You've been in a 20-year drought, and precipitation has been lower over that period. So if you look at the average of precipitation over the last 20 years, that's about 7% lower than what you've seen over the long-term average. So this figure here shows snow water equivalent in the upper Dolores Basin. So this isn't, the figure before I showed annual precipitation that was averaged over the entire county. This figure shows the average of snow that's been measured in some of the high elevation sites that measure snow here in the upper Dolores Basin. And you see the same sorts of trends. There's quite a bit of variability in the amount of snow. It varies from anywhere from as low as 5 inches to 25 inches of snow. The thing that I do want to point out is that in 2018, last year, this was the lowest snowpack that's been recorded. Granted, this record only goes back to 1987. It doesn't go all the way back to 1900. But since records have been kept in the upper Dolores River Basin, this is the lowest amount of snow that's been recorded. This figure here shows just comparing annual precipitation to annual snowpack accumulation. The blue bars show annual snow accumulation in the mountains. The orange bars show total precipitation that's been accumulated. And the point of this graph is really to show that this balance between wintertime precipitation and precipitation throughout the rest of the year. And here in this region, it's really a balance between snow that falls over the winter and then accumulates and is available for water resources, and also summertime precipitation that comes in the form of monsoonal thunderstorms. And one thing I wanted to point out is that the mean annual precipitation for the upper Dolores River Basin is 30 inches. However, in 2018, we saw less than 15 inches of precipitation in the upper Dolores River Basin. So this was an extreme drought year. To put that in perspective, this figure here shows Colorado precipitation in the water year of 2017-2018 compared to average. Where you see red colors there, that is the driest year on record. Where you see orange colors, that's in the 10th percentile, so that means it's probably among the 10 driest years that we've seen on record. So this was an extremely dry year to the driest year that's been seen. So precipitation is only part of the issue when thinking about drought and water supply. Temperature also plays a big role in this. And temperature plays a role because as temperatures are warmer, this evaporates water from rivers, lakes, and soils. So this figure here shows annual average precipitation from about 1900 through the present day. And you can see throughout much of the 20th century, although there's other places where there is a clear trend from 1950 onward of warming temperatures, actually here in Montezuma County, there wasn't really much of a signal of warming temperatures until about the year 2000 or the 1990s. But since the 1990s, temperatures are over 1.5 degrees warmer than the long-term average. And this is something that is not just happening here in Cortez. This is something that's happening throughout the region, like the small region thinking about the Four Corners, and the larger region thinking about the Intermountain West, and the even larger region thinking about the country and the globe. Temperatures are warming. However, here in southwest Colorado, that warming has taken a little while to kind of kick in. But here over the last 20 years, during this time where there's been relatively significant drought, temperatures have been warming significantly. So just to put those temperatures in perspective with the entire historical record, this figure shows how temperatures in 2017 through 2018 correlated to the entire historical record. Colors in red there are showing areas where the warmest temperatures on record occurred. Areas in orange are showing areas where in the upper 10% of the warmest temperatures, but here in Cortez, it was the hottest temperatures on record since about 1895. So I've been talking about this, but I want to really stress this, that warming alone has an impact on drought and water availability. As temperatures are warmer, there's higher evaporative demand. That means the atmosphere is drawing more water from soils, from water bodies, from plants, and there's less water available to rivers, to reservoirs, etc. And under these circumstances, this evapotranspiration is a higher fraction of precipitation. Under these conditions, that means that there's typically more rain and less snow during the winter, and especially in the shoulder seasons. That means there'll probably be more rain during the fall and during the spring. That also means there'll be earlier, and we've seen this, there'll be earlier peak runoff, and there'll be reduced annual flows in the Dolores River Basin. So I briefly want to just talk about the Dolores River a little bit. So this figure here shows the annual volume of water in the Dolores River Basin that passes through Dolores, Colorado. And this annual volume varies from less than 100,000 acre feet to nearly 600,000 acre feet. And the two things I want to point out is, one, the extreme variability you see in this. This is really similar to what one sees in precipitation. However, I do want to point out that if you look at the last 20 years of this, there is significantly lower flow on the Dolores River. And this is a signal that I think has a lot to do with climate change. The McPhee Reservoir is the primary water source for Cortez, Colorado, and very important to the viability of the community and availability of water. This figure shows the amount of water storage in the McPhee Reservoir from approximately 1984, shortly after it was, the reservoir was built, through today. And for the most part, the McPhee Reservoir holds quite a bit of water. It was only in the early 2000s and 2010s where reservoir storage dropped to relatively lower levels. So this gives one a sense of how much water is available within the McPhee Reservoir. That average storage was about 290,000 acre feet throughout the course of the record. So when thinking about drought, there's sort of two perspectives that one can think about. One, the historical perspective, thinking about how long that we have maintained records throughout here in Southwest Colorado to actually physically measure temperatures, precipitation. But we can, as scientists, we can gain some information that tells us something about past climate and water availability. This figure here comes from some studies that have been done with tree rings to understand the flow of the Dolores River, looking into time frames further past in the historical record. And the thing that I want to point out here in this particular graph is that there's some periods prior to 1900 where stream flow was extremely low. And the point that I want to make with this is that while there have been low stream flows in the Dolores River, there has been drought here over the last 20 years and the last 120 years, that the drought that could happen here might be more severe than what's been experienced in the last 120 years. And this long-term record of stream flow on the Dolores River tells us something about that. So just to summarize what we've seen in southwestern Colorado and the upper Dolores River Basin in the last few decades, temperatures have been significantly warmer during all seasons. Precipitation is highly variable. Even though climate change is having an impact on this region, it's not discernible whether climate change is increasing or decreasing precipitation. It's basically been variable. However, there has been a significant drought since 2000. I know I am talking about drought, and it's been an exceptionally wet winter. So it's been a wonderful recovery from this drought, and that's great, I think, from all perspectives. However, that doesn't change the fact that there has been nearly 20 years of drought here in this region. I also want to bring up the point of extreme weather. Extreme weather conditions are increasing, and that is a general prediction of climate change. By extremes, I mean extreme periods of drought. I mean extreme periods of heavy precipitation. So maybe monsoonal thunderstorms in the summer change. Maybe winter snowstorms become more severe. All of these sorts of weather events are likely to increase in their severity. They might not happen as frequently. There may be prolonged periods of drought in between them, but it is likely that these sorts of weather extremes will increase. Overall, just the effect of warming alone, just the effect that temperatures have warmed by several degrees over the last 100 years is having an impact on the water cycle. And by the water cycle, I mean that means that the snow-covered season is changing, when it starts, when it ends, when peak runoff is. So why is all this happening? This comes to the part about climate change. So man is making an impact on climate here in this world. And the figures up here show increasing CO2 concentration, so carbon dioxide concentration, since about the late 1950s on Mauna Loa in Hawaii, all the way through the current day. And I have to say, just from a personal perspective, as a young graduate student in 2001, I first started studying ecosystem ecology and measuring fluxes of carbon dioxide from ecosystems in the Arctic to the atmosphere. And in order to do that, we first had to make a measurement of how much CO2 was in the atmosphere, just what the baseline measurement was in order to measure the change between the ecosystem and the atmosphere. And in the early 2000s, 2001, that was about 362 parts per million. Now we sit at about 412 parts per million. So regardless what one might think about climate change, we as humans have made a significant impact on the concentration of carbon dioxide in the atmosphere. And this is really driving the rising temperatures. And the figure to the right, to the left, you can see, this increase in carbon dioxide concentrations, increase in the impact of greenhouse gases in the atmosphere is driving this increase in temperature. So what does that mean for here locally? How might climate conditions change here in Cortez? So this data here is data that's specific to Montezuma County, looking at the historical record of temperature and projected increases in temperature. And here in Montezuma County, by this current date compared to 2000, there's already been, as I mentioned earlier in the presentation, about a 2-degree temperature, 2-degree Fahrenheit increase in temperature. By 2035, there'll be approximately a 4-degree Fahrenheit temperature increase in temperature, and this is under a high or a low emission scenario. The red line in this figure shows a high emissions scenario. The blue line shows a moderate emissions scenario. By mid-century, those two projections start to diverge a bit, and by mid-century, it's projected to be a 6-degree temperature increase under a high emissions scenario and a 5-degree temperature increase under a moderate emissions scenario. However, by end of century, that temperature increase becomes even more distant between the two emission scenarios, with approximately a 9-degree temperature increase by 2100 and a 6-degree temperature increase under a moderate emission scenario. I do have to say, just as kind of personal commentary on that, we are currently on a high emissions trajectory. Unless our country and other countries around the world take seriously reducing emissions of greenhouse gases, we will be on that high emissions trajectory, and that's what's likely to occur unless we do make some changes. So when we think about precipitation, so one thing I'd like to talk about when thinking about climate models, like climate models are kind of these esoteric things to talk about, and they don't, there's so many complexities with those. Climate models are really good about projecting temperatures. We as climate scientists are really certain that temperatures are going to increase. Precipitation is much less certain. So when I talk about like impacts of climate change, I like to focus on temperature and the impacts of temperature. So that can be things like early snowmelt, reduced snowpack, things like that. However, this figure here shows projected changes in precipitation in Montezuma County. And as you can see, it looks a bit like a scatter graph. There's not any discernible trend in precipitation. If you actually crunch the numbers, there is a slight projected increase in precipitation for Montezuma County. However, that's going to be highly variable, and it's probably not something to necessarily count on moving forward. So finally, I just want to talk a little bit about how extreme events may change in the future. Heat waves are likely to increase in their both severity and frequency. Drought is also likely to increase in both its frequency and severity, as are wildfires. Those three things are very linked issues that impact this community here. On the other side of the hydrological coin, so not just the dry side of things, but the wet side of things, it's also likely that heavy precipitation and flooding may increase too in this region. It will happen infrequently, but those sorts of events will happen. And with those events, you may also see an increase in debris flows and landslides, and also increase in severe winter storms as well. The one thing that will decrease is seeing outbreaks of extreme cold weather here in this region will likely decrease. So thinking, I kind of want to leave this conversation with giving you with a bit of a forecast of what the climate might look like here 10 to 30 years out, so thinking closer to mid-century. Temperatures every year from now will likely be 2 to 7 degrees warmer than what the historical average is. And that the warming trend that wasn't present throughout the 20th century will very likely be present here going forward in the 21st century. In terms of precipitation, there's probably not going to be a discernible trend. For centuries, the southwestern region of North America has seen extreme variability in temperature, and there's very complex climate phenomenon that impact the fluctuations in precipitation in the southwestern U.S., not just here in Cortez, but throughout the entire southwestern U.S. Those extreme fluctuations in temperature, in precipitation, are likely to continue and will probably become even greater. That this fluctuation in precipitation will become the normal pattern. Overall, when thinking about just the water cycle, thinking about water availability here in Cortez, there will be an overall decline in snowpack over the next 30 years. That will probably be on the order of a 10 to 30% decline in snowpack, spring snowpack accumulation by mid-century, and runoff will also decrease. There'll be a change in the timing of runoff, but the overall amount of runoff will also decrease on the order of 5 to 20%, and peak runoff will likely occur in May rather than June. And when thinking about extreme weather events, over the next 30 years, you'll probably see another 1 to 4 severe drought events. And that might not be just single drought years, it might be multi-drought years that are stacked up upon one another. You'll also see extreme precipitation events too. I'm certain there will be years where there's heavy snowfall, like this year, and there may be years where there's heavy monsoonal thunderstorm precipitation as well. And with that, I'd be happy to take any of your questions. Thank you. Yes, sir.
You want me to go to the microphone or just?
That'd be great, if you wouldn't mind. If everyone wouldn't mind going to the microphone so we can get, we're live streaming this and recording it. Thank you.
So I have a couple of questions. One of them is I'm on a water well, and I've got water at 130 feet, and I assume that water is coming from the precipitation that's coming from the rivers and wherever it comes from. But can I expect that water level to go down? Because you just got through saying maybe there won't be that much change in rainfall. I was actually been reading about it, and instead of talking about temperature, if the temperature increases by 5%, the Southwest will be basically uninhabitable because the Colorado River will be down to a trickle and the snow runoff will not have enough water and the temperatures will be high. So I don't know, that sounds like that maybe wasn't valid information, but so the question is, can I expect my water level where my well is to keep dropping?
So I want to address the first part of what you said. I think the statement you made is extreme in saying that if temperatures increase, that the Colorado River will be down to a trickle. Projections are that the Colorado River Basin will have lower flow moving towards 2050 and 2100. But a trickle is, I think, an extreme way to put that. But more importantly, thinking about your groundwater levels, I'm not an expert in groundwater, so I do want to preface this comment based on that. However, warmer temperatures just mean that there's less water going into a system. There's going to be less groundwater recharge. So it's likely that your groundwater levels may continue to fall. And I do have to say that, like, groundwater is an understudied part of water availability and climate change in a lot of regions. I live in Salt Lake City on the Wasatch Front, and some of our water comes from groundwater, and I know in that region it's a bit of a black box, and that it's not as well understood as it should be. So I think there's more research that needs to go into that, but just knowing what I do know about changing climate and ecosystems, if you warm temperatures, there's going to be less water going into the ground to recharge those aquifers.
Thank you. Really appreciating your talk.
Yep, you're welcome.
Seth, could you address the dust on snow?
Sure. What do you have a question about dust on snow?
Well,
I mean, I know about it, and I can speak generally, but do you have a question?
I think you know, about how it affects runoff and
Sure.
how the heat affects the dust and the dust affects the.
Sure. So here in this region, this is probably the one or two places in the world where dust deposition on snowpack has a really tremendous impact on water availability, timing of runoff, and things like that. So that's for a couple reasons. One, there's a very high mountain range right here, so it acts as kind of a catcher's mitt for anything blowing from the west. The second reason is that in the Colorado Plateau to the west here, there's a lot of terrain that has dust that can be picked up by winds. And that has something to do with management practices. I'm not an expert on land management and grazing management practices, but certainly grazing animals over the Colorado Plateau over the last 100 years has had a significant impact on soils in the Colorado Plateau and makes those soils more available for transport by wind. When those soils can be transported by wind, they're going to be carried downstream. And here, the San Juan Mountains provide a place to catch that. Once those soils, that dust gets deposited on snow, it all of a sudden completely changes the energy balance of that ecosystem. By that, I mean that think about if you wear a white shirt on a 100-degree day or a black shirt on a 100-degree day. You're going to be a lot hotter wearing a black shirt on a 100-degree day. So while dust is not necessarily black, it's brown, it's much darker than snow. When that dust gets deposited on snow, it changes that energy balance. So much more radiation from the sun can be absorbed by the snowpack, and that leads to both the snow melting off sooner and overall slightly less water available in the rivers. You're welcome. Yes, sir.
I walked in and I saw these examples here of how much the average citizen uses for water a day, 200 gallons per person per day. So that's the current, usage. Given what you're saying, there'll be less water available from a conservation standpoint. Any projections on what kind of reductions in water use the city of Cortez would have to project over the next 30 years?
I can't speak specifically to that, and I might pass this off to Phil if he has a comment on it. I would say that I will make like an overarching statement in Utah and the western United States that we need to conserve water, and that's probably the first best thing to do when thinking about reduced water availability and climate change. Is let's just try and use what we have more wisely first, and then if we don't have enough water, then let's worry about getting different, like new water supplies or things like that. So I don't know what that number is. I do know that if you look at the numbers of the amount of water used per capita in Utah compared to other places in the West in the United States, Utah has extremely high usage. So I think there's a lot of room for improvement here in this. Well, I'm sorry, we're in Colorado. I'm being biased. I live in Utah. Colorado is different, excuse me. But I know in Utah in particular, there's high water usage per capita. And I think Colorado has done better than Utah has in reducing that water consumption in some areas, but I'm not sure about that in all areas.
We definitely have, we don't have a target to say we want to reduce it from 200 to 160. I think, we want to reduce our water usage, period. And right now, the city of Santa Fe uses 90 gallons per day per capita. So, excuse me, what this represents, that 200 gallons per day per person actually encompasses everything, indoor and outdoor use. I like to speak about the winter quarter, which is January, February, and March. We only use about 3,500 gallons per residential account. That's a household. That's not counting people in it. That's just a count. And then we go up to about 17,000 gallons a day during the irrigation season. So a lot of it is put out of doors. So when we say conserve water, that doesn't mean that we're going to be trying to cut back on our healthy use of it. We need it to live, and we're mostly water anyway. So, but we have to get better about using outdoor use and use it more wisely. And this is the way I look at conservation is, well, if we don't use it, it goes down the river to Powell and Meade in California and Las Vegas, and that's not how I look at it. What I want for Cortez to be is sustainable and to be able to live within its means. And if we can change how we use water outdoors and live within our means, the living block of water, that no matter, even if our existing water rights stay the same, we'll still have enough water for our quality of life in this area that we've come to enjoy. So what we really want to do is reduce outdoor use and do it smartly, not zero. It's not zero-scaping, it's xeric, because it still looks good. We don't want this to be just a bunch of rocks and dirt by any stretch. So there isn't a hard and fast goal. We just need to get better at how we use our water.
Do you have strategies to mitigate the extreme temperature rises? I mean, they're planting a lot of trees. Do you see that as a positive, negative, or really just beautification? Can you talk about what we can do locally to mitigate this threat?
I'm not. Yeah. I don't know that I can really say as much as you might like about that, but I do want to say that the project that my organization worked on with the city of Cortez was about talking about those things. About, okay, here are these climate risks, and how does that affect city management? And then how can the city change management practices to adapt to that? So I guess I'm going to pass that over to Phil.
Well, we've had a report that we developed as a result of this effort, and it is now online. It's the VCAPS, it's outward facing, and it has an appendix in it. And the appendix was just, it's basically a list of a lot of brainstorming that went on with a lot of different people in a room. And so we have a bunch of action items and impacts. And that report is out there, and I do want to say this. This is the first big push for our conservation effort here in Cortez. This is just the beginning. This is a living, breathing effort. We're bringing in the horticulturist, the botanist from the Denver Botanical Gardens on the 23rd. Is that right? I have it right here. There's flyers here too. On the 23rd. Then there's going to be edible landscapes with Vic Vanek of Four Seasons, and our local arborist David Temple is going to be doing talks about trees, and we're going to be putting all of these out on our website. So I would say go to the website, look at the outward facing report. There's the appendix there that has action items and impacts, and that way you'll have the information that we discussed. And I would hope that this is just going to be a launching pad for a lot of interest and input from the community. And it's not just Cortez. you know, we all live in this area in Montezuma County. We're all in this together. We have 2 concurrent systems that we treat water for. One is the Blue Door, and then we treat tribal water and send that down to the Ute tribe. So we're all connected, and that's why it's outward facing. And we have an email address, which eludes me right now. Is water is what is it? Jeez, oh Pete, thank you. I've had a very long week, but what? Water's our future at cityofcortez.com. Thank you. And it's there, and I'm open to any and all input as well as our staff is. So.
Have any municipalities succeeded in graywater development for irrigation purposes?
Oh yeah, there is huge. In the state of Florida, even in Arizona, for instance, they have 2 distribution systems. They'll have purple pipe, which would be reclaimed water, and then blue pipe for potable. So this is not anything new by any stretch. And we have we have a centralized sewer here, which goes down and discharges into McElmo Canyon. So that is something that is on our radar for sure. It's a source of water. We just haven't had, the opportunity to really get in depth into it. Yes, ma'am.
Seth, I was interested in your comment. You said water conservation is the first step, and then the second step is to begin to look for other sources. What other sources are possible for finding for supplying water?
Oh gosh, I think I may have misspoken here in Cortez. And thinking about my bias of living in Salt Lake City, where in Utah there are some possibilities at developing new water sources. So here in Cortez, I don't think there are any others.
No. We have one bowl, and that's it, the Dolores River Basin and McPhee. And there's actually limited groundwater resources, but they're on the rivers. They're the underground rivers that people tap into in the Dolores. We don't have the ability to even tap into groundwater here. So that's why I've been very concerned about this, because we have one straw and one straw only, and it's all dependent on snowpack.
Well, the graywater could be a source.
Yes, it could be. Yes, sir. Yes.
So we've been talking about quantity, and with the reduction in quantity, I'm wondering, is there a metric to predict potential ranges of quality impacted by reduced quantity? Because I've heard a saying at like a mining summit that dilution is the solution of pollution. So the less water we have, does that mean our particulate matter parts per million is going to increase because we have hard rock mining up in our upper watershed area of the Dolores River, as well as your residual background contamination? Is that something we need to be concerned about as well?
I do really quickly want to address one thing you said. As being a wastewater professional, the dilution to pollution is not the solution.
No, that's
so yes, there'll be less water to convey the materials, but there'll also be less water to scour them. And we also have the McPhee is actually kind of like a settling basin for us. When it's full, right now when a McPhee is shallow and the water's coming in cold, it really short circuits right to our intakes. So it would have more of an impact, I think, during low levels of McPhee reservoir as opposed to when it's has more settling ability.
I guess I'd just say, like, whenever there's low flows in any river system, temperatures will increase in those rivers or lakes or reservoirs, and there's the potential for impact of, various sorts of pollutants having more of an impact, like algal blooms.
Right.
I'm not saying that's an impact here. I'm just saying it's a general sort of thing.
Yeah, and Dolores is classified as a cold water amphibian habitat too, so that quality level is pretty high, so temperature would definitely impact that.
Yes, yes, temperature can be an impact, and this is something we've seen. throughout the West where rivers are shifting in their temperature regimes. You know, for example, the Jordan River in Salt Lake City is listed as a cold water fishery, but the reality of it right now is it's not really a cold water fishery anymore. So that particular watershed is impaired because of warm water right now, but the reality is it's not really impaired, it's just changing.
Right, but by water words.
Yes, yes. But I think you're a long ways off that here in the upper Dolores, because you're here at 6,000 feet.
Here.
Yeah. And even higher in the upper watershed. So I don't see that being a problem anytime soon with fishery habitats changing in the upper Dolores. I don't see that happening.
They have more of a metal sloping problem.
Yes. Yeah, it's you have some buffer with temperature in this watershed, I believe.
Any other questions?
I have a question.
Yes, sir.
Will the effects of prescription drugs in the water supply afterwards, after we use it, affect the usability of water downstream? If so, is there any way we can affect that change?
Well, that's an ongoing problem right now with regards to pharmaceuticals and hormones in water supplies, and that's global. I mean, but I think a lot of it has to do with concentrated wastewater streams discharging into watersheds, which we don't have on the Dolores. Like, we don't have any wastewater plants upstream. So yes, it's an issue, and I know that treatment technologies are problematic. I mean, you're talking about reverse osmosis and/or membrane filtration at that juncture, or even more stringent than that. So, but I don't think that's going to be an issue here. Go ahead. No, you can go ahead, sir. Shooting from the hip right now. Let's go for it.
Question about carbon. Like, you had CO2 level. So in doing some reading about the climate changes going on, is one of the things to do is reduce carbon in the atmosphere. And that's like use less petroleum products like fracking product. What about burning fields? Is there carbon in the grasses, and when you burn that up, does that release carbon in, or CO2 or carbon into the air?
Yes, it absolutely does. When thinking about accounting for carbon, meaning like carbon budgets, like how much do people burn, how much do ecosystems take up carbon, generally burning of ecosystems, so that releases carbon to the atmosphere. No doubt about that. Like, ecosystems will, a forest will take up carbon from the atmosphere, carbon dioxide, and then if that forest burns, that's released to the atmosphere. The same thing goes with grasslands. So if there's a natural balance of that to some degree, and I would say the impact of burning on climate change is if it tips in the direction of there's more burning of ecosystems, be it through wildfire or deforestation or management of certain areas by burning, versus uptake of carbon from those ecosystems, then that starts to be a problem. So excessive burning, can contribute to climate change because it puts more carbon in the atmosphere. I don't know if that answers your question or not.
The question is like, I try to heat my home with firewood.
Yeah.
And is that a better thing to do than invest in a solar system and try and not burn wood?
Oh gosh, I think so. I have to admit, like, that gets into vagaries of this, right? Because the sort of the general idea is that oh, well, trees, they take up carbon dioxide, and ultimately those trees will fall down, and they'll decompose, and that carbon will be released into the atmosphere in the same form of carbon dioxide. That happens over a very long period of time, right? If you can imagine a tree growing, falling down, decomposing, and all of that carbon being lost to the atmosphere, that's several hundred years. So if you're burning that wood, it speeds up that cycle quite a bit. So I don't have a good answer to that. And I think about that a little bit myself. I do. I'm not sure what the right answer for it is. In terms of carbon accounting, typically like burning biofuels is considered a good thing for climate change because, well, that's carbon that was it's already going to decompose anyway. However, if you burn all that carbon really quickly, then that's putting more into the atmosphere. So I'm sorry, but I don't have a really clear answer of that for you. You're welcome. Yes, ma'am.
At this point, do we have any idea of how demands in the lower basin states will impact the amount of water we have available up here in the upper basin? Because they're going to be in the same situation as everyone else. They're going to have less water, and there's Phoenix that want more water, and Tucson, Las Vegas. What will happen there? Who has the first right? Us or them?
Well, that's a very good question. It's an ongoing debate everywhere, and I was at a meeting yesterday in Durango at the Southwest Basin Roundtable, and the consensus amongst people in different states that have different water rights is they don't want to talk about it. They really don't want to know, because if they talk about it and it gets out, and this is going to get to litigation, so they figure they're going to be giving away things, information, and from where I sit and having to make sure that everybody in this city and everyone in this area has drinking water, I would rather rip the Band-Aid off and know how bad it's really going to be, so I know what I'm up against and I know what to tell everybody and how we have to react. And I said that a little. I used a little more words to say it than that, but that's what I said, and I don't know the answer to that, man. I don't. It's very tenuous at best. We're getting a breather. Like everyone here knows, we've been in this exceptional drought, and we got a really good snowpack. So we got a second, and that's all I look at it as. We got a water year, which is really, we're going to blink and it's going to be gone. So. Yeah, and we're going to be disseminating that information as much as possible on our website. It's really like basically 2 sheets of paper right now, but it is going to blow up, and we're going to have a lot. We'll be keeping everybody up to date with any information we know specifically to that situation.
I would just add that the issue you're speaking of, it will be an issue that has to be dealt with here in the Western United States in the next couple decades, and I'm not going to proclaim I have a solution or suggestion or even expert advice on that, but there is a simple issue that the Colorado River Basin, the water in it, was divided upon a compact that was determined during an extremely wet period in the 1920s, and there's not that much water available. And looking forward with climate change, there will be less water available. And currently, the water in the Colorado River is not fully apportioned. So there are upper basin states like Utah and Colorado who, I think in theory, they'd like to develop those water resources. But they aren't currently fully developed. So there's conflict between climate and development of water, and it will be. All I can say really is it will be an issue moving forward that has to be addressed systematically. I don't think the old system's going to work for the next 50 years.
The western states are just fighting with one another at
we'll
I mean, I
see.
think every state's concerned about that, but I don't think there's any real answer to that. Yes, sir.
I'm a little confused on what you mean when you say development of water. Development of water. What would that be?
So I guess I'm gonna confess that I live in Utah and work in Utah, so I'm thinking about Utah. By development, I mean new water projects that bring water from the Colorado River to places within a state. So, for example, there's a plan to develop a Lake Powell pipeline from Lake Powell to St. George, Utah. That would be an example of a water development project.
Yes, sir.
So thanks for coming. I'm curious about your research models that express information to us. These conversations have been going on for a few decades now, and it seems like you all being climate scientists have had a chance to review your models and your techniques. How do you feel about these climate models and the different, I'm assuming it's software that you plug all your data into and you get these outputs. How do you feel about trusting these climate models and using?
I feel really good about them. I think that climate models that give the projections that I, distilled into like 2 graphs for slides, I think that these climate models are extremely good. And the thing that's great about climate models and the techniques that scientists and universities have developed these days is that we can not just say what's going to happen over like a huge area. We can actually say what's going to happen. We can give projections about what's going to happen on, say, a 5 mile by 5 mile grid cell that accounts for the difference in climate between here in Cortez and at 10,000 feet, not too far outside of Cortez. That under climate models, the large scale climate models, they just kind of average all those things together. They're on a maybe 1 degree by 1 degree resolution, like 1 degree on the globe. So that means that's 100 miles by 100 miles. And I think all of us know that the climate and weather varies quite a bit. When you think about the West, in a 100 mile by 100 mile area, it's going to vary from 4,000 feet to maybe 14,000 feet. And that's going to make a tremendous difference in climate. So I feel really confident about those, Sam. The thing I feel most confident about that I think I mentioned once during my talk is that climate models are extremely certain about changes in temperature. Changes in temperature are going to continue to increase, and that's a real certainty with climate models. Climate models are a little less, they're a little less certain about precipitation in general, but here in this region specifically, climate models are a little less certain. If you move to, say, the northwestern United States, precipitation is projected to increase, pretty certainly. If you move to Arizona, a little southwest of here, precipitation is projected to decrease. But here in this region, it's kind of in one of these zones where it's in between. So precipitation is a little less certain for this particular region, as it is throughout, much of Utah and a lot of the Intermountain West. Welcome.
With your temperature model, will skiing be a viable industry in the 21st century?
I sure hope so. I'm a diehard skier myself, sir. And I'm teaching my 8-year-olds how to ski, so I hope I'm not setting them up for just distress later in their life. So that's a really good question. I think that there's places that, all joking aside, I think lower elevation ski areas are going to be less viable. Higher elevation ski areas will be fine. And in fact, if you look at temperature and precipitation, so precipitation actually, not in southwest Colorado, but if you look at like, you know, kind of further, like more towards like Summit County, Aspen, those areas, precipitation is projected to increase, and temperatures are going to be cold enough because it's such high elevation that snow is actually projected to increase because there's that buffer in elevation because it's so high. So high elevation ski areas, they're going to be totally fine. The lower elevation ski areas, they're probably going to struggle a little bit. You know, you know, like Purgatory here, you know, they're at what, 8,000 feet or something like that. I think they'll be fine. But some of the lower elevation ski areas, if I'm thinking about Colorado, I'm thinking about like Eagle County, places like the bottom of Beaver Creek or Vail, you know, where it's about 7,000 feet. Those places might start to be, you know, they're going to get some rain. And historically, those places, it doesn't ever rain. You know, and thinking to my state, to Utah, there's, you know, a bunch of ski areas that have bases of 5,000 and 6,000 feet elevation. And those places are going to be severely impacted. However, places, you know, with base elevations of 8,000 feet, what's that? Alta, yep. My wife works at Snowbird, so I'm thinking in Little Cottonwood Canyon, Alta, Snowbird, they'll be fine. You know, 2100 might be a different story, but they'll be fine for a while. It will just be a change in the season. I think ski areas will be impacted by perhaps winter not setting in as soon as ski areas are used to, and Thanksgiving not being a viable time for ski areas to be open for, and, you know, snowmelt happening sooner. So those will be impacts. But I think the ski industry in both Utah and Colorado will be fine for the discernible future. There'll be some areas that struggle, but mostly fine.
Yes, ma'am?
Yes, ma'am.
How do you see this affecting the agricultural community as far as growing seasons and the different crops that they can grow in this area?
Well, I'm not an agriculturalist and I'm not a rancher or a farmer, certainly, but I can tell you that, you know, having water in the reservoir is going to help them have their irrigation season. With regards to what is a viable crop, I don't know. I think that would be a good discussion to have with Ann when she comes up here. Karen, would she be able to address those kinds of things?
I would think she'd be able to provide some information on that, so Mark, the 22nd of the
And there's flyers over there too. Yes, ma'am.
How exactly do you conduct the tests where you test the precipitation to the runoff to the evapotranspiration?
So you're talking about like some of the numbers I provided that like on average 30 inches of precipitation falls and 20 inches goes to the atmosphere. Honestly, that's kind of from basic scientific research and measurements that are made that we can make those estimates. So those numbers I gave, the precipitation numbers are totally spot on. The evapotranspiration numbers, they're estimates. You know, it's based on observation, but they're estimates there. But the point with that evapotranspiration and climate change is that the amount of water that leaves an ecosystem to the atmosphere will increase as temperatures increase. And I think that's you know, a really key point that I was trying to make in my presentation, that even if precipitation stays exactly the same here, that if temperatures increase, there'll be less water available for plants to grow, for crops to grow, for water to run off into the McPhee Reservoir. You're welcome.
Yes, ma'am.
I'm trying to understand all of this.
That makes two of us.
I heard you say something about action items that are already proposed on a plan that the city has done already.
Yes, ma'am.
Okay. That's on the City of Cortez website.
It is?
And then it's called waterisourfuture.com.
Yeah, well, there's a tab on the banner of our website. It's called Water is Our Future. You can click on that. It'll bring you to our reports, our conservation plan, our conservation brochure. What else, John, would be on there? Just the reports currently, and then we're going to be adding content for...
And upcoming events of which there was only Seth because he's the first time.
Right, and upcoming events and whatnot. Yes, ma'am.
There will eventually be links for research if you want to, we'll provide you with some links.
Right.
For sites you can go to if you want to know something about waterwise plants, for example, or xeriscape landscapes or whatever. I mean, if you get involved in this, there'll be more of that kind of stuff.
Fine.
Research to figure out how to city assess
website, and then click on Water is Our Future. And all this information is there, an action plan for what to do in Cortez and share. Already
Well,
developed.
no, not an action plan, no, ma'am. It's an appendix that is like it's an appendix like this. This is not like this. This is it. It's an action and an implication. This is basically just the group of people, the 12 of us that got together with Seth's group, and we brainstormed, and we put this list of things down, and this is what they are. And although we came up with it, our hope is that it's just going to stimulate contributions from our constituents, from people who live in the city and in the county. And then the website is going to be developed as we move forward. We're going to have landscaping information there, like the mayor said. We'll have various links to different research areas. One of the things that we want to do from the water treatment side is have snowpack levels, McPhee levels, production levels on the plant, daily consumption levels on our side, so we can track and show how well you guys are doing in making those water jugs go away on a daily basis. So there's only a couple of things on that site right now because we're just getting it developed.
Thank you.
You're welcome. Any other questions, comments?
Still, there's the email address, if I want to say that again, and that's for questions, comments, concerns, and also ideas that people have to bring to
Which is waterisOurFuture@cityofcortez.com. And that is on our webpage.
I'm sorry.
That's on the page?
It is now.
Yeah, okay. And it is an active website.
Email it.
Email address, I'm sorry, yeah.
Do you know if there's any research, any studies that are being done to figure out ways that might possibly be cost-effective for reducing the amount of evaporation on reservoirs like McPhee or Lake Powell? I mean, if it reaches the point where water becomes scarcer and scarcer, what's the potential for maybe covering those areas so it reduces the evaporation? Is there anything being done on that you know of?
Sure. Certainly, if you're thinking about climate change, temperatures increasing, there will be more evaporation from any reservoir, and especially in really hot desert climates. Maybe not quite as much McPhee, but Lake Powell and other Lake Mead, places like that. I know a little bit about some of that research. The best example I can think of off the top of my head is that there was a small reservoir in California in the 2015 drought that they basically deployed a massive amount of these black balls across the reservoir so that those black balls absorbed the radiation from the sun and didn't evaporate water. So I think in that specific case it worked pretty well, but it was a pretty small reservoir. That's not really a viable thing for a lot of reasons in a place like Lake Powell or even McPhee Reservoir. So I don't know of a solution to that. There is some research on it though.
No other questions? Oh yeah, I was gonna. Well, okay, well, I guess, do you have anything else to say, Seth?
I don't, unless anyone else has any questions. Thank you for inviting me here to speak. I appreciate it.
I did want to say thank you all for coming. I'm really impressed with the turnout. We've done public information meetings before, and staff has outnumbered participants, so thank you. There's some water bottles over there with our new logo on there. Please take one with you on your way out, and come back to our website and check it regularly. We're going to be updating it and have more, these opportunities out there. Let me say a couple of them, reiterate a few. On April 23rd, Waterwise Landscaping, Andy Barrow from the Denver Botanical Gardens. Oh, I'm looking at, okay.
Everybody invited for that.
Okay. April 22nd, thank you. Thank you all.
Thank you.
Thanks, Seth.
You're welcome.